Today, we're diving into a crucial topic: application security, which is vital for all software. This involves protecting our software throughout its entire lifecycle, from the initial design phase right through to its deployment. So, what exactly is a secure SDLC, or Secure Software Development Lifecycle? Let's explore its definition. It integrates security into every phase of development, identifying and mitigating risks from planning to maintenance, ensuring security isn't an afterthought. Now, let's look at the key objectives of implementing a secure SDLC within your development process. Our main goal is to build software that is both resilient against attacks and fully compliant with necessary regulations. First, we aim to identify potential security risks as early as possible in the development process. This allows us to address vulnerabilities proactively, preventing them from escalating into major, costly issues later on. Another key objective is to build robust and strong software that can withstand various attacks. We ensure applications are resilient against common attacks like SQL injection and cross-site scripting, protecting user data. It's also crucial to ensure that our software meets all necessary regulatory compliance standards. This means meeting standards such as GDPR, HIPAA, and PCI-DSS right from the very beginning of development. A significant benefit is minimizing overall costs and saving valuable development time. Fixing flaws early on saves considerable resources and time compared to addressing them after deployment. Finally, implementing secure SDLC significantly helps in improving your organization's reputation. By delivering secure applications, you build trust and confidence with your customers, enhancing your brand. Let's now explore the 6 distinct phases that make up the secure software development lifecycle. Remember, security is not just a single step, but rather integrated seamlessly into every stage. The first phase is planning, where we lay the groundwork for our secure application. Here, we define the scope, establish security requirements, and conduct essential threat modeling for the project. Next, we move into the design phase, where security is architected into the system. This involves integrating security architecture, designing access controls, and planning data protection strategies carefully. The third phase is development, where the actual coding of the application takes place. We follow secure coding practices, implement rigorous code reviews, and utilize static analysis tools. Following development, we enter the critical testing phase to find and fix vulnerabilities. This includes penetration testing, dynamic application security testing, and comprehensive vulnerability scanning. After successful testing, the deployment phase focuses on securely launching the application. We ensure secure configurations, proper access controls, and robust application monitoring from day one. Finally, the maintenance phase is an ongoing process to keep the application secure. This involves continuous monitoring, patching vulnerabilities promptly, and conducting regular security audits. Let's summarize the significant benefits that adopting a secure SDLC brings to your organization. Essentially, it represents a proactive and forward-thinking approach to ensuring application security effectively. One major benefit is significantly enhanced security across all your applications. It proactively identifies and addresses potential vulnerabilities before they can be exploited by attackers. Another key advantage is the substantial reduction in overall development costs. Fixing issues early avoids costly post-deployment breaches and expensive remediation efforts later. Achieving and maintaining regulatory compliance becomes much simpler with secure SDLC. It integrates crucial privacy and security considerations right from the very beginning of development. Surprisingly, secure SDLC can actually lead to a faster time to market. By fixing security issues early, you reduce delays that would otherwise occur later in the cycle. Finally, a strong, secure SDLC dramatically improves your organization's reputation. It builds invaluable customer trust by consistently delivering secure and reliable applications that they can depend on. Now, let's look at the OWASP Top 10 Vulnerabilities, which are critical risks for web applications. These represent the most critical security risks that every web application developer should be aware of. First up is injection, a common and dangerous vulnerability in many applications. This occurs when malicious data or commands are executed by the database, leading to serious issues. It can lead to unauthorized data access, modification, or even a full system compromise. Next, we have broken authentication, a flaw in how users prove their identity. This category covers weaknesses found in login mechanisms and session management processes. Attackers can then impersonate legitimate users or escalate their privileges within the system. Sensitive data exposure is another critical vulnerability that we must address. It's the failure to adequately protect sensitive data, whether it's stored or being transmitted. This can unfortunately result in serious consequences like identity theft or financial fraud for users. Finally, let's discuss broken access control, a common issue in many applications. This refers to improper restrictions placed on what authenticated users are allowed to do. It allows users to access unauthorized resources or perform actions they shouldn't be able to do. We'll compare two crucial application security testing methods, SAST and DAST, essential for protecting your software. These are two distinct and effective approaches to testing your application's security thoroughly. First, let's explore SAST, which stands for Static Application Security Testing, a powerful technique. SAST is a white box test, directly analyzing your source code, bytecode, or binaries for flaws. It's excellent for catching vulnerabilities very early in the software development lifecycle. SAST works by meticulously analyzing code patterns without actually running the application. A potential drawback is that SAST can sometimes generate false positive alerts, requiring further review. Now, let's look at DAST, or Dynamic Application Security Testing, a different but equally important method. DAST is a black box test, examining a running application from the outside. Just like an attacker, it finds vulnerabilities during runtime by simulating real-world attacks on the live system. A key advantage is that DAST doesn't require access to your application's underlying source code. DAST excels at detecting vulnerabilities that attackers might exploit in real-world scenarios effectively. Let's define what code reviews are and why they are so important for application security. Code reviews are systematic processes where developers examine peers' source code to identify errors, improve quality, and ensure security. We'll now dive into the key principles that guide secure coding practices for robust applications. These principles are all about building security directly into your code from the very beginning. First up, we have input validation, a critical step for preventing many application security issues. Always sanitize user input thoroughly to prevent dangerous injection attacks from happening. Next, let's consider the principle of least privilege in designing your applications. This means granting only the minimum necessary access to users and processes at all times. Effective error handling is another vital principle for writing secure and stable code. Make sure to avoid exposing sensitive system details in error messages to potential attackers. Authentication and authorization are fundamental for controlling access to your systems securely. Implement strong mechanisms to verify user identity and manage their access effectively. Finally, data encryption is absolutely essential for protecting sensitive information securely. Always protect sensitive data, both when it's stored at rest and when it's being transmitted. Now, let's discuss securing APIs and microservices, which are vital in modern applications. APIs and microservices are crucial but create attack surfaces. Protect them with robust authentication, data encryption, and input validation. Let's quickly recap the main points and key takeaways from our discussion today. Here are some essential key takeaways that you should definitely remember from this lecture. Remember, a secure SDLC integrates security into every single phase of development. Proactive security measures can significantly reduce costs and enhance compliance requirements. The OWASP Top 10 lists the most critical web application security risks to be aware of. SAST and DAST are complementary testing methods, each providing unique security insights. Code reviews and secure coding practices are fundamental for building resilient applications. Finally, APIs and microservices always require a layered security approach for robust protection.